everybody, I'm Leigha.
And I'm Nikita.
And welcome to the Data Cloud live demo. If you're just joining us from this morning's keynote and spotlight, you heard some of the latest innovations we launched. Earth Engine, Spark on Google Cloud, Psql Interface for Spanner, and Vertex AI Workbench, all to help organizations solve their most complex data-driven challenges. In this live demo, we're going to take complex, fragmented data systems and simplify them, bringing together data on a massive scale to explore a real-world scenario for climate and supply chain analytics.
In order to do this, we're going to need the whole data team. Say hi, everyone.
Hello, I'm Brad.
Hi, I'm Derek.
Now, a quick reminder, this demo is truly live and you can engage with us directly. So ask questions, say hi in the chat window, and hit those emojis.
I think I see some coming in now. I see lots of hearts and fire, a lot of people saying hello in the chat. Thanks everyone for joining us today. So if you can't see the emojis or the chat, just go back to the Next Event website and click on the blue Join the Interactive Experience button.
Okay, let's have a little fun with this. Today, you're actually joining us for our weekly stand-up at Symbol Superstore, a fictional US-based grocery chain focused on sourcing from local producers. Like many different industries, we need to bring together disparate data sources to build resilience. Specifically for us, drought in the western US has impacted our producers, and our supply chain has been disrupted with decreased shipments week over week. We need to better understand how to manage inventory and to prevent stockouts, and ensure we can scale in both how we analyze information and how we run our transactions.
All right, team, so to address the supply and scale challenges that Nikita just mentioned, we have 4 different workloads. First, I'm going to evaluate the best climate information to identify at-risk producers. Then Brad will mature our data pipelines to transform that data. Next, Derek will dig into scaling our transaction processing. And finally, Nikita will show how we're gaining new insights by evolving our data science capabilities.
Let's get into it, and let's keep hearing from all of you out there, our data pros. Leigha, you're up first.
Great, thanks, Nikita. So in order to gain insight into our supply chain, first I need to evaluate the risks. So I'm focusing on figuring out how drought impacts the very source of our grocery products. And to do this, I turn to Google's platform for earth science data and analytics, Earth Engine, which has a huge catalog of satellite images for things like climate, weather, croplands, and much more. There's currently over 50 petabytes of data in the catalog. Plus, more and more images are added each day. So let me just go ahead and bring up this cool little application that I built using the Earth Engine code editor, so I can walk you through the 3 data sets we'll be using today. First is going to be crop data from the USDA NASS program, which I can grab right from the public data catalog by searching. So this data set is going to contain 1 image of the US for each year, going back all the way to 1997. And each 10-meter pixel in this image has actually been assigned a crop type. Let me just close out of this here, bring you back to my app. So the second data set contains the outline of agricultural fields. And we're going to use Earth Engine to assign each one of these fields the crop type that is most prevalent among the cells that cover it. So in this view that I'm showing right here, the pink fields are alfalfa and the dark green fields are almonds.
Leigha, these visuals are super helpful, but could we export this data for analysis in other environments?
Yep, I'm actually going to push this into cloud storage and BigQuery in just a sec, but first I want to add in some additional signals on drought. So the third data set that I'm using is a collection of both short and long-term drought indicators, meaning that we can see what drought looks like for each field over time. Now, using data sets like these does require some deep subject matter expertise. So special thanks to our real-world partners at Climate Engine, who build solutions on top of Earth Engine's API, helping organizations ground their analytics projects with scientifically accepted methodologies. Okay, so you just saw how we use geospatial data, and I want to know how you use it in your analysis. So go ahead and answer that poll so we can see. All right, everyone, so with these layers in place, we can start exploring drought risk. Let me just go ahead and zoom to this field. And here I'm going to show an almond orchard northeast of Modesto, California. And what we're looking at is the long-term drought indicator. So this orange tint that you're seeing means that this field has experienced pretty high levels of drought over the last 5 years. Now, if I go ahead and just zoom out a bit, we can actually see that the entire Central Valley in California is pretty drought stressed. So my last step was to calculate drought risk for each of the fields I showed before. And this will tell us which farms and produce types are potentially at risk for not meeting customer demand, which is just one consideration to inform Symbol's resilience strategy. Better yet, we can incorporate this geography data with other spatial stuff like store and customer locations that are already inside of BigQuery. And anyone who knows me knows that I love BigQuery. If you agree, let me see in the emojis. All right, so the code editor has been great for interacting with Earth Engine, but making these calculations at scale requires a different approach. So I went ahead and created Earth Engine tasks for batch processing to run these calculations over all the data in 5-day increments for the past 10 years. I also set up a cloud function to run every 5 days going forward so that we'll always have fresh data. Now, just as a quick recap, we jumped into Earth Engine to evaluate earth science data that indicates climate risk for our farm fields. Now we'll have fresh drought data available in cloud storage. So just think of the power of integrating huge amounts of specialized data, giving us a complete picture of supply risk for our business. Oh, and I think I can see the poll results coming in now. It looks like lots of people are using geospatial data for all different kinds of things. And if your answer wasn't in the poll, just go ahead and let us know in the chat. So next up, Brad will transform and push this data into BigQuery for geospatial analysis with our existing data. So Brad, over to you.
Okay, that was pretty cool, Leah. Thanks. All right. So to gain more insight into how drought is impacting production, my main focus has been building out the data transformation pipeline to push farm field drought indicators from cloud storage into BigQuery. Speaking of batch processing, as you know, to assist with inventory management, price optimization, and product assortment, we use Spark to standardize our large-scale data processing, and we use Google Cloud Dataproc as our long-running clusters. For you data pros out there, we'd love to know how you're using Spark today. So let us know while I go ahead and pull up the Cloud Console. So here is a Dataproc cluster we currently use to schedule PySpark jobs. And here I'm connected to a Jupyter notebook running on the same cluster with some PySpark code. This code is typical boilerplate code you'd write to do basic data transformations. In this case, we are processing the Earth Engine files from cloud storage, performing type checking and mapping to ensure proper ingestion into BigQuery using the Spark BigQuery connector.
Hey Brad, so this is pretty cool, but I think having a batch workflow that's scheduled on a continuously running cluster seems like it can be kind of wasteful. So is there any way we can make this more efficient?
That's a fair point, Leah. There is still some overhead in management here. And for hardened batch cases like this, it would be preferred to have these jobs run on their own discrete resources. But good news, with the new serverless option for Dataproc, we can submit a PySpark job without spinning up any infrastructure. These auto magic capabilities, I can spend more dev time writing code and less time on managing infrastructure.
All right, Brad, first off, I'm pretty sure that you just set me up for that. And second, you definitely made up that word automagic.
Yeah, but can I get some emoji love for that? Anyway, I'll now go ahead and export this notebook to a Python file using nb-convert. Okay, and next, let's go and use the Cloud SDK to submit a serverless PySpark job. We can use the Dataproc API and call batches to submit a serverless job. So I'm showing you here a PySpark job, but I can also submit Spark jobs written in Scala, Java, R, or SQL. With auto provision and auto scale, no infrastructure configuration is needed. This helps those less familiar with how to fine-tune their Spark jobs to utilize its powerful distributed data processing model. With these capabilities, there's no need to manually create and tune clusters. So once I've submitted the job, I can show it listed in the serverless Spark console, and I can click on the job to view its logs. Now, serverless Spark takes about a minute or so to auto provision the resources as well as start writing out log output. So what I'll go ahead and do here is show you the log output from a completed job that I ran earlier. So if we click in here, we can see, okay, so I added some print statements into this job, and here it's showing me that there's some short-term drought data that's processed, some long-term drought data, and then some geographical data as well. Now, in addition to this, I can also show you the Spark history server, which is where the more details of the Spark job itself will be outputted once the job has been completed. So we can go back and debug. And then additionally, we can also gain access to metadata via Dataproc Metastore. Now, in addition to all of this, we are also looking into a new solution for creating long-running clusters or a place where our infrastructure team can manage Dataproc clusters. Now, fortunately, we feel that Spark on GKE fits our use case and lets us utilize our existing GKE infrastructure. So clearly, it's been a busy week for me using Spark serverless to create pipelines to push drought data into BigQuery. But the efficiency improvements we'll gain by not needing to manage cluster overhead will be worth it. Now, you can let me know in the chat if you're as excited about Spark serverless as I am.
OK, let's see how everyone's using Spark today. Looks like notebooks are pretty popular.
Oh, and automation through Airflow. That's cool, too. OK, great. Thanks so much, Brad. So now that we have greater insight into supply risks, we need to scale our transaction systems to handle more orders and allow us to understand the potential business impact of these climate risks, while hopefully lowering costs. So this brings me to Derek, our DBA. Derek, you've been focusing on this effort, so can you let us know where you're at today?
Yeah, absolutely, Leigha. We have a new grocery chain that has struggled to maintain their on-prem databases as they've grown. There's an opportunity to solve their underlying scaling problems with Cloud Spanner. I spent the last few weeks validating Spanner's ability to scale and the ease of maintenance while keeping strong consistency for this point-of-sale workload. I migrated some of the new chain stores to Spanner already. Using granular instance sizing, I only provisioned a portion of a Spanner node to handle the required load. As we move the remainder of stores, we can easily scale up without downtime or app changes.
Quick question, Derek. We've been really focused on reducing the cost and complexity of building scalable applications. So I'm wondering, how does adding Spanner impact that effort?
Yeah, that's a great question, Nikita. One way we've been doing this in other environments is to standardize on Postgres. Postgres is a well-established open source database with an active ecosystem that our development and ops teams are already familiar with. I tried to get the team to add an elephant emoji so y'all could show some love for Postgres, but anyway. Spanner just announced a PostgreSQL interface. This gives us the benefits of Spanner without having to completely retrain our application teams. Having a standard API for our data will help us maintain velocity for new features, even as our database needs evolve. Here, let me show you. So I've connected into our Spanner instance using the PSQL command line tool. From here, I can explore the schema just like I would any other database, any other Postgres database. You can see that both the Postgres data type and the Spanner data type is available to the information schema. So this will make it familiar to anyone who already knows Postgres.
Awesome. Thanks, Derek. This is really cool. I'm really looking forward to the scalability that this is going to bring our team.
Absolutely. And as a quick summary, I highlighted how Spanner allows us to get started small and scale as needed using granular instance sizing, and how the new PostgreSQL interface reduces friction for our teams already familiar with Postgres. Nikita and Leigha, you can treat the existing data as golden, and I'll keep onboarding more stores. Nikita, I believe you need this data for some of the big query analysis you were working on. You've been busy figuring out how to evolve our ability to make sense of all this data. Can you show us how that works?
Yes, absolutely. I was hoping that you'd ask. So to ensure that we're managing stock to meet customer demand, my focus this week was on evolving our data science capabilities for exploratory analysis. I combined the transactional data that Derek's been working on with the drought data that Leigha and Brad pushed into BigQuery. This way, we can gain insight into which products are most at risk of not meeting customer demand. So my first step was to integrate all of our transactional data within BigQuery, primarily using Federation with Cloud SQL and Spanner. This provides a unified environment for aggregation and analysis where we can join transactions back to producer details and the associated drought risk scores. Now, as you all know, we recently migrated to Vertex AI Workbench, which has really helped with our basic compute and resource management.
Quick question, Nikita. Is Vertex AI Workbench a notebook for Vertex AI?
That is an excellent question, Derek. Vertex AI Workbench contains recently updated managed notebooks, which bring forth more integrated data engineering capabilities into our data science environments. So we can ingest and analyze data and deploy and manage ML models all from one spot. Now let me show you a little bit about what this looks like. After I provisioned a new managed notebook, my first task was to analyze the demand on the high volume SKUs. And for that, I used the BigQuery connector to view and query the sales data. With Vertex AI Workbench, I can inspect BigQuery metadata, preview tables, and automate basic SQL construction entirely from my notebook environment. Okay, it's my turn on the emojis. I want to see the fire emoji from all the data scientists out there who are as excited as I am about being able to access BigQuery from the notebook interface. Looks like I'm not the only one.
Hey, Nikita, hold on. Sorry to interrupt your emoji fest, but I see you're working out of the Lakes project, but are able to pin other projects you have access to, like the Ops project. Is that new?
Yes, that's correct, Brad. Vertex AI Workbench actually enables me to interact with all services via my own identity. The BigQuery plugin also provides some templated code to help build out queries and project results to a pandas data frame. So here we can see, oh, looks like I just need to refresh. Sorry about that, team. I'm just going to refresh my Jupyter Lab instance here. I guess I had it open for too long.
And I guess while Nikita's doing that, like, who uses Jupyter now? Let's see the fire emojis lighting up. I see so now. I personally use it a lot in my day-to-day.
All right, thanks, Leigha. So perfect. Now you can see a simple view of all transactions by the day of week. And Vertex Workbench actually also allows me to launch different kernels entirely in the same instance. So Brad, I think you were working out of a PySpark notebook earlier, is that correct?
Yeah, so Dataproc clusters are also supported as a backend as a part of Spark on Google Cloud. We can access all supported kernels on the cluster, including PySpark.
Well, for my analysis, I just needed a Python kernel. So let me show you what's going on in this notebook and what I've been up to this week. You can see here that I've done a deep dive into the data. I've plotted the transaction volume, I've created a heat map of purchase counts across various departments, and I've also plotted the short-term drought index across various crop types, like corn, dry beans, pears, and rice. But my last task, and the most important task, was to map SKUs to suppliers and calculate a risk score based on the aggregate field data. So to do this, I started with our mapping table, which you can see a sample of right here. This helped me to determine which farm fields actually source ingredients for a particular SKU. And then I calculated a weighted risk score that takes into account each product's demand and the associated farm's overall drought risk. And you can see each of these measurements in this data frame right here. Ultimately, this score will help us to prioritize managing items where we're most at risk of not meeting customer demand. So as a quick summary, I used Vertex AI Workbench managed notebooks to connect back to data accessible from BigQuery and create a weighted risk score for each one of our products, combining both climate and demand data. Leigha, I went ahead and put all of this back into BigQuery just to keep it centralized.
Awesome. Thanks so much, Nikita. That risk score is going to be huge in helping our team understand supply risk. So to make sure the broader team has a trusted view of all this information, I started incorporating everything into a Looker dashboard. Now with Looker, we define our metrics like average risk using LookML, Looker's data model. And Looker uses this to compile SQL queries and send them back to BigQuery on our behalf, so that our non-technical users can explore the results of these data efforts. So let me show you this dashboard that I've been working on. And first off, you can see this custom map layer that I use to visualize drought risk across farm regions in the West. And we're able to take advantage of BigQuery's geospatial functions and drill from this aggregate view all the way to producer or even grocery product level. Let me show you. So I'll drill to field ID, and then I can jump right into Looker's Explore to bring in some more fields. Like maybe I want to specifically look at products that are at risk in this region where we're quickly expanding.
Making all this data accessible to the broader team is really important. So can we make sure that the marketing team is aware of this so that they know how to hold off on coupons or advertisements for these products?
Yeah, actually, we can set up a schedule from Looker so that the regional marketing teams are always notified if new products seem to go at risk. So putting this all together, we used Earth Engine to process new Earth science data signals. We use Spark to efficiently transform geospatial data and push drought indicators into BigQuery. Spanner to scale our transaction systems, ensuring we have the infrastructure to handle future growth. And Vertex AI Workbench plus Looker, backed by the power of BigQuery, to evolve our data science capabilities and surface important trends back to key decision makers. So with integrations across these services, anyone is able to explore and take action on insights that combine climate data and transactions. Now, we can understand where products may go out of stock due to increasing drought conditions and identify areas to build resilience against changes in our climate. So with this geospatial information, we're given a whole new set of data so that we can not only be considerate of our customers, but also find ways to be more considerate of our planet. And with that, it looks like we're right about at time. So thank you so much for joining us today as we've shown how Google Cloud can offer a world-class experience for creating a scalable, unified data platform. And a special thanks to my colleagues, Nikita, for showing us Vertex AI Workbench, Jarett for introducing us to Spanner and its Postgres interoperability, and Brad for walking us through Spark on Google Cloud.
And thank you, Leigha, for showing us Looker and Earth Engine. Last, but certainly not least, thank you all out there so much for your engagement. We love those emojis and seeing all of your comments in the chat. So stay tuned for our live Q&A, which is going to cover everything from our spotlight through this demo.
Thank you.
Thanks,
Bye.
everyone.
Thanks. Bye.